This video is about addition polymerisation. Polymerisation, basically, in simple terms, making plastic. Okay, so plastic comes from polymerisation. Okay, making plastic. Now, the raw material for making plastic, in addition polymerisation, is an unsaturated molecule. An unsaturated molecule has, okay, a carbon to carbon double bond. Okay, in other words, what we're really interested in here are alkenes. Alkenes are made from cracking alkanes. Alkanes are found in crude oil. Okay, so the simplest alkene that we can look at, I suppose, is ethene. Okay, ethene here has a carbon to carbon double bond surrounded by 4 hydrogens. Okay, now in addition polymerisation we have some new terminology. The unsaturated molecule, that's the unsaturated molecule there, so the ethene is unsaturated. The unsaturated molecule in addition polymerisation is called a monomer. Okay, the unsaturated molecule is a monomer. Mono means one, so it's one mer if you like. Okay, now what we're going to do is we're going to heat and pressure a container full of ethene, all these monomers, literally trillions of molecules of ethene. And they're the only thing that are there. Now, if you heat and pressure that, this double bond has a habit of springing open. Okay, so for every one of these monomers here, this double bond now has sprung open. So I've now just drawn that first monomer there with that double bond sprung open. Let's draw this one here with the double bond sprung open. Okay, so I'm just going to quickly sketch this out like so. And it's going to take a little while, so we actually need a better way of doing this that's much, much quicker. Okay, because we can't do this every time we want to show an addition polymerisation reaction. Okay, so for every one of these monomers, this one now, I'm going to draw it with that double bond sprung open. Okay, now you can't have an empty bond in chemistry, it has to join to something. Okay, so my next question is going to be, what is this opened bond going to join to? Now, hopefully you can see in the way I'm drawing it, there's only one thing it can possibly join to when you start with a cylinder full, okay, of just pure ethene. And the answer is it has to join to each other. Okay, so all these double bonds, now they're open, end up joining to each other like so. Okay, so what we start with is these very small molecules. Okay, and what we end up with is one giant molecule. And some of you now may be thinking to yourself, isn't that just like in crude oil, where you start with maybe bitumen with 40 carbons in the molecule? It's just a very long hydrocarbon molecule. It's just making an alkane again. What's the point in that? Well, it is essentially, I suppose, but it's much, much bigger. This is about 40,000 carbons long, whereas the longest molecule in crude oil is about 40 carbons long. General formula, that's going to be H80,002. Okay. In reality, and we can't draw 40,000 carbons out like this, so we need a shorthand way of doing it. Okay, so let's have a quick look at some of these other questions, then we'll look at the shorthand way of doing that. What is the name of the polymer formed? Oh, let's finish labelling this to start with. We had all these other things. If this was unsaturated, this molecule down here is saturated now. Okay, it's only carbon to carbon single bonds. If this one here was called ethene, okay, because it was called ethene, the way we name a polymer is very simple. Whatever the name of the monomer, okay, in this case ethene, okay, all we do, we write exactly the same thing and we put the word poly before it. Poly means many. So mono was one mer, now we've got many mers, okay, all joined together. And that's all the labels there. Right, so name. What is the name of the polymer formed? Polyethylene. Okay, now sometimes we shorten that in everyday use of language now to polythene. Polythene bags. Okay, plastic bags if you like. Environmental problems, non-biodegradable. That means it lives in the sea forever and ever, poisoning marine organisms and getting caught around seals, and then David Attenborough goes and puts them on primetime telly. And fair dues to him, actually. He's massively raised the problem of plastic pollution in the world, which is a really, really serious issue. Do polymers have high or low relative molecular mass? Well, very high, very high. Okay, because the molecule is so long, 40,000 carbons, that's going to be a very high molecular mass. Okay, so as I said, we can't write longhand equations out, we need to do shorthand equations. Okay, so the way we do that, we write the monomer there. Okay, instead of a moment ago we wrote lots of them, it took me a long time to do it. Okay, now I'm not going to write lots of them out because I've written one, there's no point in writing any more. So I'm going to use the letter N there to mean lots. Okay, and what we said happened is the double bond springs open. Okay, and it makes that, doesn't it? Okay, so the way we're going to say that happens lots of times, we're going to put a bracket through the bond, the bond goes through the bracket. Okay, a bracket through the bond. Okay, and we're going to write the letter N outside to show it happens lots and lots and lots of times. And that's called one repeating unit. Okay, that unit there repeat lots and lots of times. Occasionally in the exam, they ask you to do a product showing two repeating units. Well, we just do this twice. Okay, so there's our first two carbons, and there's our second two carbons, or our second repeating unit. Bond through the bracket, bonds through the bracket, bond through the bracket there. I'm going to write N times outside it. Of course, what we now need to do is put the hydrogens, whatever is on these bonds on the left-hand side needs to be on these bonds on the right-hand side. Now, this is easy. There's 4 hydrogens, so I'm just going to write a hydrogen next to each and every one of those. And that's now showing 2 repeating units. Okay. Got the question here. It's a multiple choice. So, which is the product of this reaction? Which is the product of this reaction? Okay, so first off, the double bond opens to make single bonds. Okay, so this one here cannot be right. Okay, because it's still a double bond. This carbon has got 5 bonds around it. 1, 2, 3, 4, 5. That's not right. It's got a double bond in the middle. Double bond opens. Likewise, that one cannot be right. Okay, same reason. Okay, now, what we need to look at now, we've got this, everything looks right there and everything looks right there. What we now need to look at is what's joined to these bonds. Whatever is joined to the bonds on the left needs to be joined to the bonds on the right. Okay, so hydrogen, 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 chlorine. Hydrogen, 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 hydrogen. That can't be right. Hydrogen, 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 chlorine. Okay, now that looks right. Now you may be saying to yourself, hang on, the chlorine's down here on this one, but now it's over here on this one. But if you think about it, if the molecule just turns around, okay, if you just turn that molecule around, it's still the same molecule. Okay, and the chlorine would go from this side to this side, so this one is correct. Okay, it is that one there, B. Okay, we can fill this in, but the video is going to run out of time, I think, so you can have a look at that one on your own. Show your teacher if you're not sure. The last thing I want to look at, okay, with this addition polymerisation video. Of course, there's many different addition polymers that we can have. We have this table here to tell us all about all of them. So ethene was that one, the monomer structure. Okay. The polymer name. Okay, we take the name ethene and we write poly before it. So whatever is before it, okay, we write poly after it. Okay, repeating unit, 1 structure. So that's just one of the monomers. Looks like this. Okay. Repeating unit 2. For 2 repeating units, we draw this molecule twice. Okay, there's it once. Here's it twice. Join them up. Put a bond through the bracket. There, put N outside it. Okay, and we have that. Use plastic bags. Here now we've got 3 carbons and a double bond. That makes it propene if we've learnt our hydrocarbon names. Polymer name, polypropene. Okay, now this is an absolute favourite of the examiner. getting you to draw this one out. Now look at it really carefully, okay? C, C, okay? That double bond there is now sprung open through the brackets, N times, okay? Now, lots of you will get it wrong because you want to put a third carbon in this chain, okay? But we're only interested in this double bond for polymerization. The third carbon is up there. It's now on a branch, okay? Hydrogen, hydrogen, hydrogen. That's how we do that, okay? 2 repeating units, exactly the same. Do you notice how I've just drawn that exactly the same way as I've drawn that one up there? Okay? Drawing that up in the middle now. It's got a CH3 group here. Okay, so when you have these longer chain alkenes, okay, there ends up being a branch, if you like, in the polymer chain, N outside it. We need to put hydrogen on everything else. Okay. Plastic bowls, rope. So your kitchen bowl at home, rope, so you can get polypropylene rope. Right, so vinyl chloride. Next, vinyl chloride. It's an old-fashioned name, vinyl chloride. Okay, a more common name, a more modern name is chloroethene. So it's ethene, but with a chlorine down there. So this is going to be polyvinyl chloride, because remember we just take the name of the monomer. That can be shortened to PVC, okay, or we can do it this way, polychloroethene. PVC is a much more common name amongst the non-chemist population of the world, okay, and you can have PVC windows. Okay, I'm just running a bit short on time here, so I'm just going to do the 1 repeating unit. Take this, again, every one of these repeating units just looks the same, doesn't it? Okay, just take that, okay, put a bond through it, and write N outside. It's exactly the same I've done with every single one of those. The only difference is we've got to write chlorine down here now, and then decorate those off differently. Right, tetrafluoroethene. Okay, tetrafluoroethene is carbon with 4 fluorines around it, so it needs a double bond. Okay, fluorine around everything. Right, so this is going to be polytetrafluoroethene. Bit of a mouthful. Okay, again, you can do that one because I'm running a bit short on time here. Uses for polytetrafluoroethene, it has a trade name. This one is called a Teflon. Okay, polytetrafluoroethene is a bit of a mouthful, so Teflon's what it's been shortened to, and that's the non-stick coating on frying pans. Non-stick coating on frying pans. I'm pretty sure the sofa I bought recently was Teflon coated. The idea was that when the kids drop their lunch on it, you can wipe it off and it doesn't stain it. So Teflon, a non-stick coating on frying pans, that's probably the one that you might have heard of. Plumbers use it as well in joints to stop pipes leaking. And there is a summary of addition polymerization.